Hello everyone. In this video, I'm going to talk about ionic compounds nomenclature. We are going to learn how to call an ionic compound by correct name and how to write the formula for this type of compounds. To remind you regarding the ionic compounds, let me first start with one of the basic definition for ionic compounds. We just need to remember that for ionic compounds, we are going to work on metal and non-metals. So we have this term, ion. Ion is one new species that we are going to work on this in our chemistry class. But before talking about ions, I'm going to work on the basic and simplest definition available for ionic compounds. Each ionic compound consists of metals and nonmetals. Attraction between this metal and non-metal makes ionic compounds. This attraction, we call that ionic bond. So ionic bond always make ionic compounds. So attraction between metals and non-metals. As you see here, metals always are placed in the first, they are placed in the formula of the compounds, like the periodic table. Metals on the left side, non-metals on the right side. Always when we have ionic compounds, we have the same pattern. Metal first and then non-metals after metals. Here we have two types of ionic compounds, binary ionic compounds and polyatomic ionic compounds. I'm going to say what is the difference between these two. After that, I'm going to define ionic compounds. So right now, we don't have any definition for ionic compounds. We just have this information. Metals and non-metals join to each other to make ionic compounds. One classification for ionic compounds is binary ionic compounds. Binary means two. When we have two types of elements, only two. We are going to see what does that mean, two types of elements. NaCl. This is one example of ionic compounds because we start with metal and we have non-metal. One sodium, one chlorine. So we have two types of elements. Another example, Al2O3. Look at this example. We have aluminum, Al, oxygen, aluminum as metal, oxygen as non-metal. Two types of elements. So we call them binary ionic compounds or BICB. When we say polyatomic ionic compounds, poly, it represents many or more than two types of elements. Look at this example, NaClO4. In this example, I have Na, Cl, and O, sodium, chlorine, oxygen. I have three types of elements. So whenever you have more than two types of elements, you call that polyatomic. So polyatomic ionic compounds, or in general, we call that PICP. So this example, in this example, I have aluminum, I have sulfur, I have oxygen. It doesn't matter how many of each. I have these three types of element. We call that polyatomic ionic compounds. So please keep in mind this definition or this classification we have, and after a couple definition for ionic compounds, we are going to apply some specific rule for each one. Let me back and explain or define ionic compounds. Ionic compounds composed of ions. I told you we need to have attraction. Attraction always between positive charge and negative charge, between positive ion and negative ion. So if we have a positive ion and a negative ion, this attraction we may call that ionic bond, and we are going to make ionic compounds. So you may have this new definition. First definition we had, it was if we have metal and non-metal. The second definition we have for ionic compounds, positive ion and negative ion. In the next slide, you are going to find relationship between positive ions and metals, negative ion and non-metal. So one thing I may ask you to pay attention, ionic compounds, we are going to talk about compounds. They are neutral, they don't have any charge. So when they don't have any charge, we may say positive charge and negative charge must be equal, must be same. So total positive charge, it would be same or equal total negative charge. So this is the one thing we need to consider whenever we are going to ionic compounds. I didn't want to advertise any brands here, but this is the most commonly used ionic compounds in our daily life. Table salt, sodium chloride. This is ionic compounds. It starts with metal, ends with non-metal, ends to non-metals, so we call that ionic compounds. Ionic compounds, we have these properties. They have high melting point and boiling point. So in general, ionic compounds, they have high melting and boiling points, and they are solid at room temperature. Room temperature means 25 degrees Celsius. Absolutely, I'm sure you remember that. So 25 degrees Celsius, they are solid. So in other words, we may call all ionic compounds salts. So salt in our daily life means we talk about ionic compounds, but table salt is only sodium chloride. So to remind you, we are going to work on something new in this chapter, positive ion, negative ion. Do you remember that? I told you ionic compounds consist of positive ions and negative ions. Right now, I may ask you to memorize like this. In the next slide, I'm going to explain for you. Positive ions, we call them cations. So positive ions, we call it cations. So let me work on this terminology. And negative ions, we call them anions. So please memorize this one. I prefer to use these terms, cation, anion. I don't want to say positive ions, negative ions. So when we say cation means positive, and whenever we say anion means negative. So you can easily memorize that. This is the negative, so we have anions. Whenever we are going to memorize cation, positive, it has T, cation, it has T. So right now, I'm going to remind you, whenever we talk about ionic compounds or in general salts, you will see we have like a regular 3D arrangement. So it looks like crystals. It looks like this figure that you will see in this slide. To remind you, metals and non-metals to make cations and anions to make ionic compounds, I'm going to say that metals are placed in the left side and the middle of the periodic table. We call them metals. So I'm sure you remember that we call this group of elements main metals, and nonmetals are placed on the right side of the periodic table. And for transition metals, they are placed in the middle of the periodic table. Please understand, look here, look at the transition metals. So they start in the short columns on the periodic table, and they are short columns on the periodic table. Let me erase that one. And we have this extension for the transition metals. They are placed in the middle of the periodic table in the short columns, and they pretend up to metalloids, So this group of transition metals, they extend by these metalloids. So another side of the periodic table for transition metals, they extend up to the metalloids. Please pay attention. Aluminum is not placed in the transition metal side because transition metals start with the short columns. Look, aluminum is not transition metal. Aluminum is the main metal. So let me write it here. Aluminum is main metal. And whenever we are going to talk about transition metal, they are placed up to metalloids, So this is the place of the transition metals. So the reason I'm going to express that one and I'm going to remind you because we have a different naming rule for transition metals. So metals, non-metals, they join each other to make ionic compounds. All right, guys, this is a time to understand the meaning of ionic compounds by the technical terms. Ionic compounds composed of ions. What does that mean, ions? Ions means negative charge element. Sorry, let me write this like this, charged element. Charged atom. Charged atom. So if we have this one, we call it ion. If I say Na, I'm talking about sodium atom. If I say Na1 positive, look here, this atom has charge, so I call that ion. So charged atom means ion. We have two types of charges. It means we have two types of ions, positive, negative. Example for this, Cl is chlorine. So in the periodic table, so chlorine atom, if I write something like that, Cl1 negative, it means I'm talking about ion, chlorine ion. So it doesn't matter, you may write Mg2 positive, aluminum 3 positive. So they are examples of ions, example of positive ions, example of cations. So because we call that positive ion is cations. Negative ions, Cl1 negative, oxygen 2 negative, nitrogen 3 negative. So they are examples of ions. Why do we have negative? Because we are going to answer this question. Negative ions, we call them anions. Right now, I'm going to work on this definition. Metals make cations. So if I have metal, I have positive charge. I have cations. Magnesium, positive charge, cation. Aluminum, metal, cation. Look here, it says nonmetals make anions. Nonmetals placed on the right side of the periodic table. Anions. Cl1 negative, oxygen 2 negative, nitrogen 3 negative. So let me back to the previous slide. So let me erase this part, this, Okay, it looks like I draw many arrows here. Alright guys. So if you remember that, I told you metals make positive ions or cation, positive. Transition metals, they are metals, positive. Aluminum, main metal, positive. And I said non-metals make anions. Non-metals form this. So in this side we have negative. So positive, negative. So in the middle we have metalloids. So whenever we have metalloids, so metalloids sometimes act like metals, sometimes act like non-metals. So they are in general negative charged. Right now, I'm going to talk about how to find these positive and negative. How to find out sodium has one positive, magnesium has two positive. So this is the rule we need to work on this. Metals in group 1, 2, 3, they follow like this rule. Group number is same as charge of cations. So group number is same as charge number for metals. Group 1, 2, 3. Please look at this one. Group 1 always make one positive. Group 2 always make two positive. And group 3, aluminum as a main metal, make three positive. So if I'm going to say sodium, always sodium has sodium one positive. If I have potassium, always potassium has one positive. If I have, for example, calcium here, calcium group number 2, always two positive. Aluminum group number 3, so Al 3 plus. So always we have like this one. Group number same as charge number. So I may ask you to please memorize that one. Metals make cations and charge for main metals. Main metals, they are placed on the main groups. One positive, two positive, and three positive. Look at this slide. It says for non-metals, they are placed, for example, group number 6, 7, and something like that. Charge for anion is group number -8. Group number -8. We are going to know what does that mean. Please look at this formula. Charge number is going to be calculated. Group number -8. Look at this slide, please. For example, chlorine. Chlorine is placed group number 7. Do you remember that? 1, 2, 3, 4, 5, 6, 7. So we say that 7 minus 8, it gives us 1 negative. So always group number -8 for non-metals or in general anions. Non-metals make anions, charge is same as group number -8. So non-metals are placed on the right side of the periodic table. So group number 4, 4 negative. Group number 5, 3 negative. Group number 6, 2 negative. Group number 7, 1 negative. Group number 8, 8 minus 8, 0. So when we say, for example, Ne group number 8, 8 minus 8, 0. So it looks Ne cannot make ion. It looks group number 8 elements cannot make any ions. So noble gases, they don't make anions. They don't make any ions. That is why we call them, they are stable. They are stable. They are noble gases. They have least activity. They don't make any ions. So let me work on a couple examples. I told you in the previous slides, Cl1 negative. Look, Cl group number 7, 7 minus 8, 1 negative. So whenever we say 1 negative, you don't need to write the 1. You can easily omit to write 1. Oxygen. Oxygen group number 6, 2 negative. So I do recommend you guys, whenever you have periodic table, so please write the charge for the groups. Metals 1, 2, 3 positive, and non-metals 4 negative, 3, 2, 1 negative, and like this one. Nitrogen. Nitrogen group number 5, 3 negative. So as you see here, we may have like this. All right, guys, so just 1 second. All right, guys, let me continue that. So right now we are going to continue talking about ions. First, cations. As you remember that we have two types of metals, main metals and transition metals. For main metals, it means they are placed on group number 1, 2, 3. We can easily find the charge of ions like the group number, like we did that one. But whenever we have transition metals make different types of ions. They make a variety of ions. For example, if we have Fe, Fe can make 2 positive and 3 positive. So that is why we don't have any rule to determine charge of transition metals. So that is why we focus on only group 1, 2, and 3. After some slide, I'm going to talk about the transition metals. So you can easily find the charge for each element. So you don't need to memorize anything. Look at the periodic table, charge number, same as group number. Whenever we are going to work on the non-metals, if you remember that I told you group number -8. One thing we should know, whenever we have anions like F1 negative, Cl1 negative, we call anions like this: non-metal plus IDE. Ite. So for example, I have Cl1 negative. So if I am going to call that one, I call that chloride. I call that chloride. So we add IDE to the root. If we have Br, we call it bromine. Br1 negative, we call that bromide. So always if you have any anions, if you have negative charge, so you just need to add IDE. So look at this, N3 negative, N3 negative. So you just need to know what is the name of this. Nitrogen plus IDE. I drop this one and I call that nitrite because we add to the root. We add to the root. So let me clean up here. It is that one to make sure you get this. Nitrite. If we have sulfur, we call that sulfide. So if you have negative charge anions, we may use like this one. In case we have positive ion, you don't need to say anything. Sodium ion, potassium ion, calcium ion, magnesium ion. You don't need to add any suffix or prefix to the metals. But non-metals always we have IDE at the end. Work on this example. What do you call each one? I'm going to ask you to write your answer or review the answer in your mind. So after some seconds, I'm going to work on this one. All right, guys. Look at the answers. See, are you able to get the correct one or not? Whenever we have metals, So you just need to report that these elements, they are positive charged. So we just need to say barium ion, aluminum ion, or you just say aluminum, barium, something like that. If we have nonmetals, you have to add IDE at the end. IDE at the end. All right, guys. So right now we are going to work on the first type of ionic compounds. If you remember, we call that BIC, binary ionic compounds. What does that mean? It means we have only two types of elements. Two types of elements. To remind you, ionic compounds, we have cation and ions. So I combine these two to remind you metals make cations, non-metals make anions. Right now, metals at the beginning in the first, as we knew that, and the name is same. Whenever we are going to follow the naming rule, it would be same. So we call that non-metals after metals. But you just need to remember that for the non-metals, we use IDE. So the rule is like this. Naming rule of binary ionic compounds. BIC. Cation plus anion. What was the definition for cation? Metals. What was the definition for anions? Non-metals. So metal, non-metals. What was the rule for anion naming? So we say non-metal plus IDE. Non-metal plus IDE. So metal, non-metal, IDE. Metal, non-metal, IDE. We are going to see what does that mean. I'm going to call the name of this compound. NaCl. Two types of cation and anions. Two types of metals. NaCl. So metal, non-metal, IDE. Metal, non-metal, IDE. How about this one? Metal, non-metal, IDE. So we have like this one. Alright guys, right now we are going to know how to write the formula between them. How to write the formula between this one. So let me give you one example. I'm going to write the formula between sodium. Question is like this. What is the formula between sodium and oxygen? Let me write sodium and oxygen. I'm going to say a three-step strategy. Three-step strategy. It's super easy if you follow like this. First, write the chemical symbol. Chemical symbol. The second one, find the charge. Find the charge. And next one, cross and down the numbers. Numbers. We are going to know what does that mean. Okay guys, please look here. Three-step strategy to write the formula. Sodium, I write Na. Oxygen chemical symbol is O. So first step, write the chemical symbol. Sodium, oxygen. It's super easy. Always you have the periodic table. Then find the charge. What is the charge for each one? Sodium group 1, always 1 positive. If you remember that for metals, charge is same as group number. Oxygen, group number -8. Group number 6, -8, 2 negative. So charge for Na and oxygen written here. Always you have periodic table, you don't need to memorize. Then cross and down the numbers. NaO. Look here, I'm gonna write charge for Na, charge for Na. Cross means write this one for this and this one for that. So we call that cross. And done because we are going to write on the as a subscript. So 2 for Na and 1 for oxygen. And we don't write 1. So the formula is Na2O. Na2O. This is the method we use to write the chemical formula of the ionic compounds. So you just need to cross and write down on the right side of the any elements. Why do we need to have like this one? Because as you remember that I told you total positive charge must be equal to total negative charge for ionic compounds. Look here, what is the charge for Na? 1 positive. How many Na do we have? 2 Na multiplied by 2. So it looks we have 2 positive charge. 2 positive charge. How about oxygen? What is the charge for oxygen? 2 negative. 2 negative. Positive charge is same as negative charge. That is why we use this method. So this method is going to help us to write the chemical formula of any compounds. Right now, I may ask you to look at the formula for ions and see are you able to write the chemical formula between each two ions or not. You may pause this video and after 30 seconds back here and see the answer. Alright guys, right now between these two, I'm going to explain for you here. La1 positive, oxygen 2 negative. So you just need to cross this one. 2 for lithium and 1 for oxygen. Li2O. Are you able to call that one by the correct name? Binary. 2 types of elements. So you just need to say lithium oxide, metal, non-metal ID. How about the next one? Al3 plus and Cl1 negative. Al3 Cl1 negative. We need to write this one here, this one here, and we don't write 1. So we call that AlCl3 formula for this compound. What is the name? Metal, non-metal IDE. Aluminum chloride. How about the next one? Are you able to get this? So Mg2 plus N3 negative. Switch them. 3 for magnesium, 2 for nitrogen. Mg3N2. This one. What do you call that? You may call that magnesium nitride. So in this slide, you will see why do we need to cross and down the numbers. So it helps you to understand we need to have these ionic compounds because the total charge is 0 for each ionic compounds. One thing I am going to ask you regarding this 3-step strategy, I'm going to say we need to report simplest ratio between numbers. You are going to know what does that mean. So question says, what is the formula between aluminum and nitrogen? Between aluminum and nitrogen. Look here, What is the charge for aluminum? Al 3 positive. What is the charge for nitrogen? Group number 5, 1 negative, 3 negative. 5 minus 8, 3 negative. We need to switch the charges. 3, 3. So here you can divide both numbers by 3 because you are going to report simplest ratio. So if I divide by 3, and let's see what happens. 3 divided by 3, 1. And for nitrogen, 3 divided by 3, 1. And we don't write 1. So this is the ALL. So we call that aluminum nitride. If we have the numbers 3, 3, 2, 2, 2, 4, 3, 6, any numbers that you can simplify, please simplify them. I may ask you, please write that one. It would be very helpful if you can combine each row and columns in this table. Please pause the video and after 3 minutes back here and see, are you able to write the correct formula and their name? Please, formula and name. 30 seconds for each one. All right, guys. So let's try and see, are you able to write the correct name and formula for each one or not? You are going to combine Na and Br. So write the formula and name. Double check your answer and see if it's correct or not. If you have the correct answer, good job. Thank you. If you don't have, please work on the next slide. We are going to have more practice. I'm sure after more practice, you are going to get the method, how it works. Write the name of each compound. What is the naming rule? Metal, non-metal, IDE. When we have binary ionic compounds, binary ionic compounds, big, two types. So double check to make sure you have the correct answer. All right, guys, I'm sure you are prepared for some learning check. Question says, what is the chemical formula for magnesium oxide? Magnesium oxide. So if you don't see that one, this one is better. What is the formula of magnesium oxide? I'm going to write the formula. Magnesium oxide means oxygen with 2 negative charge. Magnesium 2 positive charge. How to find it out? Because of the periodic table. Magnesium group 2, 2 positive. Oxygen group number 6, 2 negative. So formula, 3-step strategy, we wrote 2 things, so you just need to switch that one. 2, 2. You may simplify them. MgO. So this is the chemical formula for that one. Or we may apply another methods available in the textbook or in this slide. Next one. Name of this compound, MgBr2. What do you think about that? What is the name of this compound? Binary ionic compound, metal, non-metal, IDE. Magnesium bromide. As you see here is the correct answer. What is the formula of sodium oxide? What do you think? Sodium oxide. Sodium oxide, group number 1, group number 6, 2 negative. 2 for sodium 1 for oxygen, and we don't write 1. So as you see here, we have sodium oxide. All right, guys, I talk about main metals. Right now, I'm going to talk about another group of metals. We call them transition metals. If you remember that, I told you transition metals are placed in the middle of the periodic table, and we cannot find the charge for them. So let me have this slide for you guys to remind you what I'm talking about that. Look, we already talked about main metals. If we have transition metals, we don't have group number for them. So we cannot say what is the charge for each one. So to do that, when we have the transition metals, we are going to apply a new rule. This rule is easier one. It says if you have transition metals, you need to use Roman numbers in the parentheses to indicate the charge. We are going to know what does that mean. I told you this example, Fe2 plus, Fe3 positive. Iron has two different charges, 2 positive, 3 positive. Right now, if I'm going to write the name for this, I say iron, charge for this is 2. I use the Roman numbers. What is the charge for this? 3. I use Roman numbers, 3. So always charge we write in the parentheses. You don't need to look at the periodic table to find group number and something. It's easier. This charge is here. This charge is here. So if I say, for example, copper parentheses 2, so you should say copper means Cu, 2 means 2 plus, always positive because they are metals. So they are something you should know that. Roman numbers means like this: 1, 2, 3, 4, 5. Look here, 5 is V, and 1 before 5 means 4. 1 before V means 4. 6 means 5 and 1. 5 and 1 means 6. So after that means positive. Before that means subtraction, negative. So 4, 5, 6. You may continue that 7, 8, 9, 10, and something like that. Guys, I ask you, please memorize. Always you have questions regarding this. We never use Roman numbers for these three ions: zinc, silver, and cadmium. Zinc, silver, and cadmium. Zinc always 2 positive, silver 1 positive, and cadmium is 2 positive. Please write for yourself. We never use Roman numbers for these elements. These elements. Please read this slide. After 30 seconds, I'm going to explain for you what does that mean. All right, guys. In this slide, we discuss about two different methods. One method is systematic method or advanced method that I already talked about this. We use Roman numbers to explain charge of transition methods. Another method, we call that old-fashioned method. We may use some suffixes like os and ik to call the transition metals. So if we have like this, larger number ik, lower number, smaller number means os. We prefer to use the first method. So for our class, I use this method. Based on your textbook, we use this method. But if you use some other textbook, some old-fashioned textbook, classical textbook, or some textbook that we have from the other countries, we may see this method as well. But for our class, our focus only on the first method, systematic naming method. Again, please don't use Roman numbers for zinc, silver, cadmium. Please memorize that. Zinc, silver, cadmium. Don't use Roman numbers for them. Alright guys, as you see here, we may have for chromium these two types of charges. Iron, these two. Cobalt, these two. Copper, or something like that. But you don't need to memorize any charges for these elements. As long as you see chromium 2, it means chromium 2 positive. If you see, for example, this one, tin, 1, 5, so 1, 5, it means 4, it means Sn for positive. So please understand that. Right now, I'm gonna work on naming rule of the compounds. So if we have CuCl, let me write the formula here. What is the name of this? CuCl. Naming rule, 3-step strategy. We wrote this one. Right now we are going to write the name. Binary ionic compounds. Binary ionic compounds. Metal, non-metal, IDE. Metal, copper. Non-metal, chlorine, IDE. Chloride. Question. We have transition metals. I have to use Roman numbers in the parentheses. What is the Roman number for this? Look here, copper. What is the charge for this one? We have no idea. I always recommend you to follow this strategy. It's easy to find the charge for copper. Look here, what is the charge for chlorine? What is the charge for chlorine? Group number 7, 7 minus 8, 1 negative. So we need to have same positive charge here. Same positive charge here. 1 positive. So I write 1. The reason we need to have this one, because for ionic compounds, total positive charge is equal to total negative charge. So whenever you have transition metal, please look at the non-metal. What is the charge for this? You just need to write that one as a positive for your compounds. Right now, I may ask you to have this practice. What is the name for this one? LICL, metal, non-metal, IDE. What is this one? Metal, non-metal, IDE. What is this one? Metal, non-metal, IDE. But please look here, PB. Look at the periodic table. PB is a transition metal because it's placed in the short columns and is extended by its period before the metalloids. So whenever we have transition metal, we need to use Roman numbers. How to write this charge for this one? Look here, I told you. Please look at the non-metal. What is the charge for this? -2. So for PB we have 2 positive. So for PB we write 2. How about the next one? Pb is lead, and I need to know what is the charge for Pb. Look here, oxygen is 2 negative. How many oxygen do we have? 2. So multiple by 2. 2 times 2 negative, it means 4 negative. So charge for Pb is 2 positive. One more time. PbO2. Please look. What is the charge for lead? I should write something in the parentheses and oxide, because it's a binary ionic compounds, metal, non-metal IDE. What is the charge for oxygen? Oxygen means 2 negative. How many oxygen? 2 oxygen. Totally 4 negative. So charge must be 4 positive. 4 positive means IV. Same scenario for other ones. But please remember that whenever you have zinc, whenever you have silver, whenever we have cadmium, we never use Roman numbers. We don't have something after their name. So we never have zinc parentheses something. We never have silver parentheses something, and cadmium as well. So please don't pick the answers if we have Roman numbers. We never use Roman numbers for them. Please answer these questions quickly. Which one is the correct one? Fe2S3, iron sulfide. Iron is transition metals. How to find what is the charge for that? So, what is the charge for this part? Sulfur is 2 negative. Group number 6, 6 minus 8, 2 negative. How many sulfur do we have? 3 minus 6. So I need to have positive 6 here. How many iron do we have? 2. So it means each iron has 3. Each iron has 3. So I need to pick this one. But easier way, if you have like this, you may switch that one. You may say 3 belongs to Fe and 2 belongs to S. So if you move backward, it's up to you which one is easier for you to get that one. I recommend you guys this one. This method, it would be very safe, because if you forget that one, that oxygen is negative 2, you may pick another answer, incorrect answer. So the correct answer for this one is copper 2 oxide, and for this one is iron 3 sulfide. Please look at these examples and make sure you are able to solve them. So like this example we had. Next question, what is the formula between correct formula for each question? Copper 1 nitride, lead 4 oxide. So you may pause this video and answer these questions. All right, guys. To answer this question, I'm sure you have the correct one. Copper 1, it means Cu, and you know what is the charge for that. Nitride means nitrogen, and we have group number 5. 5 minus 8, 3 negative. I'm sure you are able to get the correct one. 3, 1, and we don't write 1. Cu3n. Hopefully, we find all of the answers correctly for this section. Lead 4 oxide, lead Pb, IV4 oxide, oxygen group number 6, 2 negative. We switch the numbers. 2 for Pb, 4 for oxygen. Guys, we can simplify. Divide by 2. Divide by 2. PbO2. Please never pick this one. It's incorrect. Always simplify it. when you have ionic compounds. So I'm going to write it here. Ionic compounds, we need to have simplest ratio between atoms, between charges, between numbers. So we already talked about this. So this is another example if you would like to know what is the name of this compound. What is the name of this compound? So this is the transition metals, chromium. We write the chromium. And we have the non-metal chloride. All right, we have transition metals. I have to write something here because it's not zinc, silver, cadmium. How to find it out? Chlorine group 7, 1 negative. We have 3 chlorine multiplied by 3. We have 3 negative charge. We should have 3 positive. 3. All right, guys. I think that's enough. When we have binary ionic compounds. Right now, I'm going to ask you, remember polyatomic ions, polyatomic ionic compounds, peak. If we have like this, NaClO4, 1, 2, 3 types of elements, we call that polyatomic ionic compounds. Right now, please memorize this table. This table is on your textbook. You may have this table in your handout. You need to memorize polyatomic ions when we are going to work with polyatomic ionic compounds. If you don't memorize it, you cannot get the correct answer. Different methods to memorize them. I may ask you to look at the other videos to get that one. I don't talk about this, but in other resources you may find it tricky if you find a short way to memorize polyatomic ions. Polyatomic ions in general are single ions. It means we have one formula that contains more than one atom. Look here, for example, if I say Cl, 1 negative, you call that chloride. But here in this example, ClO, 1 negative, more than one atom. ClO2, 1 negative, more than one atom. ClO3, 1 negative. ClO4, 1 negative. NO3, 1 negative. All of the examples you see here, we have more than one atom in the formula. We call that polyatomic ions. Guys, for polyatomic ions, you need to memorize them. Most of the polyatomic ions, they have oxygen and non-metal. Look, carbon and oxygen. Oxygen, hydrogen. Hydrogen, carbon, oxygen. So as you see here, most of them, they have oxygen. And this one and that one, they don't have oxygen. That is why I say most of them, they have oxygen. Another one, most of them, they are anions, except this one, ammonium. So please memorize ammonium first as a polyatomic cation and other ones as well. I do recommend you to make a flashcard. So there are some applications of polyatomic ions. They may have a variety of applications from anti-acid to preservatives to make the food enrichments. different salts, I may ask you to write the name of each one. Na2SO4. To find the name, the rule is cation, anion. Same rule. But anion is not IDE because we have a specific name for this. Look at the anion. Look at the cation, sorry. Look at the cation, sodium. What is the anion? SO4 2 negative. SO4. Look at the SO4. Find SO4 here. Sulfate. So we call that sodium sulfate. So always cation, anion. Anion polyatomic. We need to memorize that. We need to memorize that. How about this one? Fe parentheses NO3 3 times. Fe is iron. This is a transition metal. I need to write something in the parentheses. NO3. Look at this table. So for your exam, you cannot look at this table. You need to memorize that. NO3 1 negative nitrate. So I write nitrate. Nitrate. How to find the charge for this one? NO3 has 1 negative. That is why I express that 1 negative. How many NO3 do we have? 3. So totally 3 negative. So we should have 3 positive. So iron 3 nitrate. Assume that I have this name and I'm going to write the formula. I'm going to write the formula. How to do that? Iron 3. Fe, what is the charge for that? Is 3. Nitrate. Nitrate is NO3, 1 negative. So 3-step strategy. Chemical symbol, charge. Right now switch the charges. FeNO3. Please look here. 1 for Fe and 3 for NO3. Whenever we are going to transfer, whenever we are going to cross that, these 3 belongs to all of these elements here. So I use parentheses and 3. Don't multiply the numbers. You just need to use parentheses. And we don't write 1. Fe parentheses NO3 3 times. As you see here. Example for the first one. Assume that we are going to write the formula for this one. Sodium sulfate. 3-step strategy. Sodium means Na. Sulfate SO4 2 negative. What is the charge for Na group 1? Then you need to switch them. 2 for Na. 1 for this. We never write 1. Na2SO4 as you see here. I may ask you, you know the rules, you know the methodology, you know everything. We had enough examples. The only thing is new is polyatomic ions. So you just need to memorize that. It's not good, but you have to do that. One thing I'm going to help you to have better understanding whenever you are going to memorize. If you have 2 different ions for one element like this, NO2 1 negative, NO3 1 negative. Always we have ATE for ions with more oxygen atoms and ITE when we have less oxygen atoms. What does that mean? If I look at the table, I see this one is nitrite and this one is nitrate. Based on this, it says ATE, it means ions or compounds contains more oxygen. 3 oxygen, 2 oxygen. ATE for more oxygen, nitrate. 2 oxygen, ITE, less oxygen, nitrite. So, what do you think about this one? SO4, 2 negative, SO3, 2 negative. If you are going to call by the name, S-sulfur. So, I'll write sul. ITE or ATE. More means ATE, less means ITE. So we call that sulfite, sulfate. But you need to know what is the charge. Charge is going to be different. Last example. I'm going to keep my examples for your exam. PO4, 3 negative, PO3, 3 negative. What do you call these two ions? Phosphorus. So you may say phos. We are going to add to the root 4 and 3. Higher number, larger one, more oxygen, ATE, phosphate. Less oxygen, lower number, smaller number, ITE, phosphite. Guys, whenever we have oxyanions, whenever we have oxygen in the ions with the negative charge, that is why we call it anions. Oxyanions means we have negative charge. They end to ATE and ITE. ATE and ITE. What was S2 negative, N3 negative? If you have only single atom, if you have only one, anion means IDE, sulfide, nitrite. If you have oxygen, ITE, AT. Please understand that. And if we have more than 2, look here, for nitrogen I have NO2, NO3. Sometimes we have 4. So the maximum number of oxygen means per, the minimum number of oxygen means hypo. What does that mean? Look at this example. For Cl we have 4 types. ClO 1 negative, ClO2 1 negative, and so on. So always for minimum number of oxygen, 1 oxygen, we call that hypo. Maximum number of oxygen, most number of oxygen here is per. First 2 ones ITE, last 2 ones ATE. Hypochlorite, chloride, chlorate, perchlorate. What do you think about this one? I may say first 2 ones ITE, last 2 ones AT. For the minimum number of oxygen, hypo at the beginning, maximum number of oxygen per at the beginning. And then our nonmetals, hypobromite, bromite, bromate, perbromate. Everything is same like this one, but the nonmetal is going to be bromine. All right, guys, there are examples. What do you call this compound? NaNO3. NaNO3. Sodium NO3. You need to memorize NO3 means nitrate. Means nitrate. How about these examples? NaNO2. NaNO2. What do you call that? Sodium nitrite. How about this one? KCN. KCN. You don't need to look at the answers. KCN. K, potassium, and Cn. Cn, you need to memorize that. We call that cyanide. LiClO2, LiClO2, Li means lithium, and ClO2, you need to remember that one from polyatomic ions, chloride. NH4I, if you remember, I told you first memorize NH4. This is the cation at the beginning of the ionic compounds. Ammonium, and I is only one single element. So we add IDE. There is no oxygen for that to end to ite or 8. So I, one negative, it means iodide. Iodide. So NH4, one positive, I, one negative. We make ammonium iodide. Guys, this section, this chapter, you need to have enough practice. That is why we always recommend you to write the formula and work on the naming rules. So you have some links to work on the more examples for this section. Thank you for watching this video. I do recommend you first memorize polyatomic ions, read your textbook, and watch this video a couple more times to understand the meaning of ionic compounds, naming rules of them. Thank you again for watching this video.